We mentioned earlier that sine squared x is a shorthand for writing sine x all squared. And the same thing is true for higher powers as well. So sine cubed x is just a shorthand for writing sine x all cubed. And as long as we've got a positive exponent here, this fact is true in general. But we have to be very careful when we see a negative exponent in either of these expressions. So caution. The expression that looks like sine to the power -1 of x is very different from the expression sine x all raised to the power -1. On the left side, the -1 is part of the function itself. So this represents the inverse sine function, also called arcsine x. This is the function that undoes the sine function. On the other hand, if we look at the right side, this -1 on the outside of the expression just represents the idea of taking a reciprocal. So this is really the same as 1 over sine x. So whenever we see this expression here, we can read it as arcsine x, and we can interchange the two notations. So we will get comfortable writing the inverse sine function in both of these ways. We can call it arcsine x or the inverse sine function. Usually saying arcsine x is a little bit faster. So this is not to be confused with the function that looks like sine x all raised to the power -1, which, as we mentioned up here, is 1 over sine x, and which is the same as the cosecant function. So we now want to focus on these inverse trig functions, and let's start with arcsine x and see if we can get a little bit of practice working with this function. The function arcsine x outputs an angle. Let's call that angle theta. Theta is going to lie between -π/2 and π/2, and it can actually equal -π/2 and π/2. So when we calculate a value of arcsine x, we're getting an angle somewhere in this interval. Well, let's try a little bit of practice. Let's say we wanted to figure out arcsine of √3/2. In terms of notation, that's the same thing as writing it out in words. So arcsine √3/2. And let's see if we can draw one of our special triangles here and figure out this value. So we'll go down to our 1√3/2 triangle. Our angles here are π/3 and π/6. Okay, and to figure out the value of arcsine √3/2, we're asking what angle gives us a sine value of √3/2. What angle did we have to put into the sine function to get a value of √3/2? Well, it might help to have SOHCAHTOA written down for us. Remember that the sine function is opposite over hypotenuse. So we need an angle that gives us opposite over hypotenuse equal to √3/2. Well, if we choose π/3, opposite has length √3, hypotenuse has length 2, so π/3 is the angle that we're looking for. Now, if we want to calculate arcsine of a negative number, let's say arcsine of -a, we can use the property that it's going to be equal to negative arcsine of a. And that is true for all real numbers. So I'm going to put a box around that. That's a general fact. So let's say we wanted to calculate arcsine of -1/2. and just to get used to the notation here, could equally well be written like this. So inverse sine function or arc sine. First thing we can do is say, well, we've got a negative number in here, so let's think of it as minus arc sine of a half. And we can go up to our special triangle and figure out what this angle is. So we want an angle that's going to have a sine value of 1/2. Pi over 6 would work, because opposite over hypotenuse for the angle pi over 6 will be 1/2. So we've got minus pi over 6 for our angle. If we see an expression like cos to the -1x, notice that the -1 is on top of the trig function itself, meaning this is an inverse cosine function, or we could also write arc cos x. So this is not to be confused with a similar looking function. Cos x, all raised to the power -1, is a different function. This is giving us just the reciprocal of cos x, which we saw earlier was secant x. So whenever the -1 is on the trig function itself, we're talking about an inverse trig function. Similarly, if we see tan to the -1 of x, we can read that arctan x, or you could also say the inverse tangent function, but that way is a little bit wordier. Now, arc cos is used a little bit less in practice. It's really arc sine x and arc tan x that are the most important inverse trig functions, so we'll focus on those two for our calculations. Let's take a look at arctan. So arctan x outputs an angle. Let's call that angle theta. And theta is going to lie strictly between -pi/2 and pi/2. So let's do a little bit of practice here. Let's say we wanted to calculate arctan of √3. Okay, it could equally well be written in words, or in letters, I should say, arctan √3, just two different notations for the same value here. So let's start by drawing our special triangle. Again, we'll draw our 1, √3, 2 triangle. Just label our angles on here. We've got angles pi/3 and pi/6. And it might help here to also have SOHCAHTOA written down. It will help keep us focused on what we're trying to do here. Now, arctan is the function that comes along and undoes the tan function. So what we're looking for here is an angle. We want to figure out what angle could we put into the tan function to get √3. Well, let's remember that tan is opposite over adjacent. So if we scan around this diagram here, if we use the angle pi/3, the opposite side has length √3, adjacent side has length 1. So tan of pi/3 is going to be equal to √3. In other words, arctan of √3 is going to be the angle pi/3. Now, if we need to calculate arctan of a negative number, we have a similar property as we saw with the arc sine function. That negative can just come out in front. And we get negative arctan of A. And that works in general for all real numbers. So we'll just put that fact in a box, general fact that we can use for any of our calculations. So let's find arctan of -1/√3. And remember, that could equally well be written in letters like this, arctan of -1/√3. All right, so again, we're looking for an angle. We're trying to figure out what angle could we put into the tan function to get this value here. And because this value is negative, we may want to rewrite this and just say this is negative arctan of 1 over root 3. And that way we can think about what arctan of 1 over root 3 looks like. So let's go back to our special triangle. We need an angle that's going to give us a tangent value of 1 over root 3. Well, pi over 6 would work. The opposite side is 1. The adjacent side is root 3. So tan of pi over 6 is 1 over root 3. In other words, the angle we're looking for is negative pi over 6. Now let's look at radians versus degrees when we're doing calculations involving our inverse trig functions. If we wanted to calculate arc sine of 0.6, remember arc sine is the inverse sine function, so we're asking what angle has a sine value of 0.6. We could try this on our calculator. And if our calculator is in radian mode, then our answer is going to be in radians. You can check that it comes out to about 0.64 radians for our angle. And if we had instead been in degree mode, we would have gotten a slightly different looking answer. So this time, try it with your calculator in degree mode. Let's see what happens. Again, we're asking what angle gives us a sine value of 0.6. You can check it would be about 36.87 degrees. Okay, and these are just two different ways of expressing the same angle. So depending what mode your calculator is in, you will either get an answer in radians or degrees. And that's why it's super important to have the degree symbol written down, or just write rad here to be clear if it's radians, so that we're sure about the units for our answer. Now, things get a little bit more complicated when we evaluate functions. So let's try a function f of x that looks like the square root of 1 minus arc sine of 2x minus 5.8. Okay, so there's a good looking function there. Let's see if we can find f of 3.3. So we're just going to try to plug in a value here and see if we can get an answer that makes sense. Well, f of 3.3 looks like the square root of 1 minus arc sine of, and plugging the 3.3 in here, this works out to 0.8. This is where we have to start to be a little bit careful about the format of our answer. So when we look at this arc sine function here, or inverse sine function, it really helps to imagine that this is going to be an angle. So we need to think about how we want that angle to be given. We really want a number here. We do not want degrees, because we're going to have to go 1 minus this value. So if we had degrees, we'd have an issue with our units. We can't mix numbers and degrees together when we're adding or subtracting. So we really need a way of getting our answer in numbers. And the way we're going to do that, just make sure that your calculator's in radian mode. That way, when it gives you the value of the arc sine function, it's going to give you a value in radians, which is a numerical value. Okay, so let's make sure that we're in radian mode. Anytime we want to make sure that our answer comes out as a number, not degrees, we'll just make sure that we're working in radians here. So f of 3.3 should be able to do this on our calculator then. And just a little bit of caution here in terms of using the calculator. When you type in your square root there, you're going to want brackets around everything under the square root, just so that the square root applies to that entire expression there. Okay, and as long as we're in radian mode, we will get approximately 0.27